Okay, this is Algebra 2, Section 9.4. It's called Common Logarithms. We're finally going to get into the calculators a little bit more and using logarithms to solve equations and help us do some things. So we showed a little bit briefly in the other video, the previous video. If you just go into your calculator and press log um, and type log of 100 or something, we said before that it's going to give you an answer of 2. And again, we kind of talked about that, and that means that the calculator must be assuming that you're using a base 10 because when we change, again, 10 to the second power is what equals 100. Okay, so there's two bases when you're using your calculator, or two commonly used ones. 10 is what your calculator assumes if you press the actual log button. Okay, and we use that one quite a bit. The other one we're going to use in the next section. And as you go on more in math, maybe into pre-calc and calc, you might use this E as a base, which we'll talk about in more detail in the next section. But for now, E is this, it's an irrational number. It's about 2.71, and it goes on forever. It's like pi is irrational. Um, there's a button on your calculator that says ln, okay, for natural log, and that has some applications also. So both of those will be kind of used quite a bit. Um, for now, we're going to be sticking with the actual log button and be assuming base 10 for this section. Okay, so let's look at a couple uses of this. Um, there's one little property that we need that actually comes from 9.3 um, that basically allows us to do something if you have a power to a power. Okay, so if you remember, let's kind of see that this is actually a little property. Um, just looking at this part right here, okay, remember what a logarithm is. A logarithm is an exponent. Okay, a logarithm equals the exponent. It's saying what power would we have to raise b up to equal x. Okay, so b to some power equals x. So a logarithm is in fact just an exponent. Okay, so if you think about this is an exponent to another exponent. Okay, this is like a power to a power kind of. Okay, and if you recall when we did properties of exponents back in Algebra 1 and earlier this year, if you ever had like something to a power and that was to another power, remember in that case we would multiply the exponents together. Okay, that's what we're doing here with logs. Okay, this, again, the first piece here, this is an exponent. Oops, I want that to stay. Okay, that's going to another power. Okay, it's a power to a power. So we multiply the exponents. So what we can do in this case is take this m and multiply it by the logarithm that they gave us, log base b of x. Okay, so it's almost like the m just kind of can be brought out front. You can think of it and get multiplied by the log. Okay, because that's what we did up here. You know, we multiplied. It was power to a power. We multiplied the exponents. Okay, this was an exponent clearly from the beginning, and the whole log itself is another exponent by definition. Okay, so we're going to use that property where if you see an exponent, if you see a log to a power, you can do a little multiplication. So let's take a look at that in action. Okay, here's an example equation. We want to solve 4 to the x power equals 100. Okay, and make sure you don't go too fast and think the answer is 25. This is not 4x equals 100. It's 4 to the x power equals 100. Okay, so again, we saw some of these earlier in the chapter, and we would try to rewrite 100 as 4 to some power. Okay, and in this case, it's not a nice number. There's no nice whole number that's going to work. It's probably going to be some sort of decimal. So let's see if we can figure this out. Okay, so what I'm going to do, let's just give myself some space here. 4 to the x equals 100. Okay, what we can do is take the log of both sides. Okay, it's something you can do. It's like an operation on both sides. It's kind of like multiplying by something, but this is not multiplying. We're taking the log of 4 to the x, and we're taking the log of 100. Okay, this one on the right side, your calculator can do for you. Okay, the log of 100 can be done on a calculator, but more on that in a second. Okay, let's use our little property here. Okay, here's that property. We're taking a log and then it's to a power. So what we can do is actually bring this x out front and rewrite this as x times the log of 4 equals the log of 100. Okay, and notice we didn't write any bases in this problem um, because we're going to just assume it's base 10 for our calculator. We're just using regular log base 10. And we're going to let the calculator do some work, but the last step we need to do is, if we want x by itself, I can just divide both sides by the log of 4. Again, your calculator knows what the logarithms are. Okay, that'll cancel, and we'll just get a calculator problem. X equals log of, you may want to put parentheses, it may open one up. Make sure you close it, and then divide that by the log of 4. Okay, so make sure, again, this is a key parenthesis here. We're taking the log of 100, and we're dividing that answer by the log of 4. Okay, if you don't close it up, you're not going to get the right answer because it's going to think you're taking the log of 100 divided by the log of 4. But we're taking the log of 100, comma, parenthesis, divide by log of 4. And this should get you an answer of right around 3.32 something. Okay, and that would be our value for x in this case. So make sure, type that in on the calculator. You got to practice that step there and kind of verify the answer there. Okay, next problem here. Um, Another one where our variable is built into the exponent somewhere. Okay, so when you see that, that should be your clue. We're trying to solve for an exponent. We're going to have to somehow use logarithms. Okay, so let's see what we can do. Let's get the variable by itself as much as we can. Okay, so that 2 sitting out front there needs to get divided out first. Okay, if we divide both sides by 2, okay, we'll have 5 to the x minus 3 power now equals 14. Okay, and again, I'm going to go ahead and change, I'm going to take the log of both sides here. Okay, the log of that equals the log of that. Okay, and what that lets us do now is we notice we do have a power here. Okay, so that exponent can get brought out front. Okay, let's just go ahead and bring that out front here. So it's going to be x minus 3 times the log of 5, and that's going to equal the log of 14. Okay, so that was that little property again from the beginning. Now just think of this as we're trying to solve for x. Okay, the log of 5 is just some number. Okay, your calculator knows what it is. Let's divide it out. The log of 5. Let's get rid of that. That's gone. Let's divide this side by the log of 5. Okay, so we're going to have x minus 3 equals the log of 14. Again, put that in parentheses and close it up. We're dividing by the log of 5, not by just 5. Okay, so if we do that right side on the calculator real quick, again, use the parentheses, it's key. Log 14, close it up, divide by log 5, close it up. That gets me about 1.6397. Okay, so x minus 3 equals 1.6397. And then when we add the 3 to both sides, we can finally get our x value. Okay, so x is going to be 4.6397. Okay, and if you're thinking about rounding, the directions are usually going to tell you round to the nearest thousandth or 10,000th, or it'll be kind of clear. If it's not clear, carry at least 2 decimals. 3 or 4 would be a little more safe. Okay. All right, let's look at another example. Okay, this one, a little bit more going on actually. We have 2 exponents and variables in both. So 7 to the t minus 2 equals 5 to the t. Okay, so again, let's take the log of both sides. It can't hurt. That's usually the way to go with exponential equations. Let's take the log of both sides. Okay, if we do that, so I just put a log on both sides, I'm going to use the property here twice. Okay, I have a log of something to a power. I'm going to bring that out front. And I'm going to do the same thing over here. Okay, I got a power. So I can bring that t out front, t times the log of 5. Okay, now we have ourselves an equation here. Um, what I'm going to do next, I'm going to distribute out the left side here. Since it's t minus 2 times something, I'm going to distribute a t to both of those. T times the log of 7 minus 2 times the log of 7. And on the right side, it's still just t times the log of 5. Okay, and this one's getting a little bit messy. Um, what I do notice, though, and what you hopefully notice, is there are two variables on here. Okay, there's t's on both sides. So one little trick here is to get those on the same side. Okay, so there's a couple ways to do it. We could either subtract the t log 7 from both sides. Maybe we can do that just to make this one step here. If I subtract that from both sides, okay, let's see what we have here. Okay, on the left side of the equation, that just cancels that out. So we still have negative 2 times the log of 7. Okay, I'm going to put the dot there so it doesn't look like a 21. On the right side here, it's t times the log of 5 minus t times the log of 7. Okay, they're not like terms. I can't combine them. Got to stay separate here. Okay, and here's why I did that. This is a little trick. Once you see it, you'll see why. The reason I did that was because now we can do a little factoring. These things both share a t. Okay, so if I rewrite this side, okay, and if I factor that t out, common factor of t, okay, so if that t is brought out front, it would just be log 5. And if that t is brought out, it would just be minus log 7. Okay, and check that that would distribute back out t times the log of 5 minus t times the log of 7. And I did that now because I can get this t by itself here if I were to just divide both sides by this log of 5 minus log of 7. Okay, again, that's just some number. Your calculator is going to do all the work for you. Log of 5 minus the log of 7. Okay, so this is just going to be a big calculator problem. Okay, so let's get this set up in the calculator here. So again, this whole thing crossed out, so that would give us t by itself. If we can just evaluate this carefully in the calculator, okay, if we use our parentheses appropriately, we should be able to handle that. So let's go ahead and set that up. So I want to do negative 2 times the log of 7, negative 2 log 7. Okay, we got to close this parenthesis up. We're taking just the log of 7. That's getting divided by, again, it's a subtraction problem down there, so let's put it in parentheses. It was log of 5, okay, close that up, minus the log of 7, close that up. And let's close up the big parenthesis that we started right after the division symbol. Okay, and that should give us our answer. Negative 2 log 7. Hang on, I need another parenthesis. Let's put another one at the beginning. I meant to put another one. Oh, I see what happened. I got too many logs in here. I don't need the log of the log. Okay, let's clear this and do this again. Sorry about that. So let's do this right. It was really, the numerator was negative 2. Hopefully you guys caught that the first time. I was just testing you there. Negative 2 log 7 minus, and then in parentheses, log of 5 minus log 7. Parenthesis, one more parenthesis. All right, not my best moment. I accidentally put the subtraction sign. It's supposed to be a division sign, and I don't know how to edit these videos, so we're going to go with it. So sorry about that. This is the expression we were looking for: is negative 2 log 7 divided by log 5 minus log 7. Okay, so sorry for all the mess there, but it's 11.55 is our answer. Right? It was negative 2 log 7 divided by. Okay. And again, we got 11.55. Okay. So again, that was just there to show you got to be careful with the calculator. I was just doing that on purpose. All right. Anyways, one last little thing. Okay, in this section. But no, seriously, be careful. It is easy to make mistakes, as you can see with the calculator. Um, one more thing. Okay. We said your calculators are going to use or assume the base is 10. Okay, it's the way it is. It doesn't give you a chance to enter a base. Um, what if the base is not 10? Okay, can we do this? What if the base is any number and it doesn't happen to be 10? Is there a way to evaluate these, on the calculator without having to go through a ton of work? And luckily there is. Okay, what you can do is if they give you a log of any base you want of some number, you can just do the log of the whatever n is divided by the log of a, and it will work out, and it'll evaluate this for us. It's called the change of base formula because it allows you to take a log of any base. Okay, and just a real quick proof or just kind of see what's going on. So let's say we have this and the base is not 10 or whatever, and let's say we want to know what this equals. So we're going to set it equal to x. Okay, so again, this is just kind of behind the scenes why this works. If we switch this to exponent form, okay, or why don't we, yeah, let's switch it to exponent form. Doesn't exponent form say that a to the x power has to equal n? Right, that's just switching forms. And then if we go ahead and take the log of both sides now, okay, log base 10, or log any base actually would work as long as they're both the same. Then the properties show that we're allowed to bring this little deal out front. X times the log of a equals the log of n. Okay, and notice what happens when we solve that for x. We solve for x by dividing by the log of a. Okay, so that is exactly what they're showing you in the formula over here. Okay, log of base n over log base a. So let's see this in action. Okay, again, you won't have to go through that proof. The problems you're going to have to do are going to be a little bit quicker, something like this. Let's do two quick ones and finish this up. Okay, let's say we want to evaluate. Okay, and we want to do this a shortcut way. Okay, we did these earlier in the section where we would say 3 to the x power. Actually, we didn't get to these quite yet, I don't think, but we're just about there. We could do it now if we wanted to. So option 1, okay, the old way. So earlier this section, and then I'll show you with the new formula we just did, it's going to be a lot quicker. Earlier in this section, what we would have done is say, all right, this equals x. I know if I change the exponential form, it's going to be 3 to the x power equals 18. Then we say we'll take log of both sides, and we do it just like we did a couple problems ago. Okay, and that's fine. You can do that. This method is going to be a little quicker, I think you'll find. Okay, so if the problem is just a log, evaluation, you're not solving an equation necessarily. What this said was, on your calculators, real quick, you can just go to log of that number. Okay, and again, close that parenthesis up, divided by the log of whatever the base is, and that should give you the answer, fairly quickly. Log of 18 divide by log of 3, and that should give you about 2.631. And that'd be your final answer for that one. Okay. So that, again, that's quicker than solving an equation, putting an x in there and all that stuff. Okay. So one last one again. It's just the log of the number on the outside over the log of the base. Okay. Straight calculator problem. Again, use your parentheses there, and you should end up with, if you want to verify this one, should be about 1.1605, I think it was. Okay. Okay. So other than butchering that one problem a couple problems ago, just kind of be careful with your calculator. Take your time on these. I know it's a little bit new, but like anything else with a little bit of practice, it'll keep getting better and better. So for some practice, this will be the assignment for tonight on page 532. We'll look at number 22 through 27. 34 through 36, and number 46.